Hello children, how are you? I was just watching an experiment, burning of magnesium ribbon that we already did in 9th and 8th standard also. Okay. Now, it was a very beautiful experiment, right? Because when magnesium ribbon burns in air, it produces a white dazzling flame, isn't it? And a white color ash is produced, which is magnesium oxide. So, why I was watching this experiment? Because today we are going to discuss the chemical reactions of metals. Okay. We have 4 reactions to study in your textbook. Reaction of metals with oxygen, number 1. Reaction of metals with acids, and reaction of metals with water, and the 4th one, reaction of metal with another metal salt solution. So we are going to study in detail one by one. Okay. Now, before going to the lesson, I just want to tell you one thing, that is, when you compare the reactivity of metals, we know that different metals react in different way. For example, when you try to burn a magnesium ribbon, you have seen that it burns quickly, isn't it? But when you try to burn a piece of gold, will it burn like this immediately? No, that will not happen. That means all metals do not react in the same way. Some metals are very reactive, some are moderately reactive, some are highly reactive. For example, if you take a piece of potassium in water, what will happen? Explosive reaction will happen. At the same time, another metal, gold, if you place in water, nothing will happen, isn't it? So, these are 2 extreme ends. We are going to learn the reactivity series and also the chemical reactions of metals in detail. Okay, let's move to the lesson. Hello children. So today we are going to discuss about the chemical reactions of metals. Okay. We have 4 reactions to study. One is reaction of metal with oxygen, reaction of metal with water, metal with acids, and the 4th one is metal with another metal salt solution. Okay. So I'll discuss one by one. So before going to the chemical reactions, I already told you different metals react in a different way. Some metals are highly reactive, some are moderately reactive, some are least reactive, as you already know. For example, sodium is a highly reactive metal. That is why it is kept in kerosene, right? And we know that metals like gold, silver, etc., if we expose to the air, nothing will happen. It is least reactive. They are least reactive, right? Alright. Now, today, before going to the chemical reactions, we want to know reactivity series of metals. Okay. What is reactivity series? It is a series in which metals are arranged in the order of decreasing reactivity. Okay. So, I have written the names of some of the metals on the board, not all metals, whatever we require in our class. Okay. So, here K indicates potassium, sodium, calcium, magnesium, aluminium. So, carbon is also included, which is a non-metal, that I will tell you why carbon is included. Okay. Just wait. Zinc, iron, lead, Pb for lead. Okay. Then again one non-metal, hydrogen. That also I will tell you why hydrogen is included in this reactivity series. Okay. Copper, Hg, mercury, Ag, silver, gold and platinum. Au, gold, Pt, platinum. One more time. Potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, copper, mercury, silver, gold and platinum. So, for writing the reactivity, for writing the reaction of metals with some other chemicals, okay, you need to memorize this reactivity series. Wait, I'll tell you one easy way to remember it, okay. What is the easy way? You know that sometimes nonsense also makes a sense, right? So I'm going to tell you a nonsense, but it makes a sense, okay. So to remember the reactivity series, that nonsense will be very, very useful for you, okay. So what is that? So here I'm going to write something, okay. So potassium I wrote please, okay. Then I wrote scent. Then I wrote camels. Monkeys. Funny, right? Monkeys. And, okay, you can write carbonated. I told you, nonsense. Carbonated. Zebras. Okay. In large hydrogen. Okay, hydrogen in bracket. Containers. Now this you can remember. Mercury, silver, gold and platinum. 4 of them you can easily remember. So thus much how to read together. Please, scent, camels, monkeys and carbonated zebras. Don't ask me what is carbonated zebras, okay. It is for your memory, okay. So please, scent, camels, monkeys and carbonated zebras in large hydrogen containers. So don't forget the order of the animals, okay. What is that? Camels, monkeys and carbonated zebras, okay. Now let's try to memorize it, okay. Please, P for potassium. Scent, S for sodium. Camels, C for calcium. Monkeys, M for magnesium. And aluminium. Carbonated carbon. Zebras, zinc. Then in iron, okay, I for iron. Then lead, large for lead, symbol is Pb, okay. And hydrogen, copper, containers, C for copper, okay. So please, scent, camels, try to keep in your memory first camels, in front of the row camels are standing, just imagine, okay. Then just behind that which one? Monkeys, camels, monkeys and zebras, that's enough, okay. Please, scent, camels, monkeys and carbonated zebras in large hydrogen containers. If you memorize this nonsense, you will remember all the metals in the reactivity series very clearly. Clear? Hope you understood. Right. So these 4 of them also please keep in your memory, that is mercury, silver, gold and platinum. Alright. Now let's move to the chemical reactions. Okay. Alright. The first chemical reaction is how does a metal react with oxygen? Okay. So here I wrote metal plus oxygen. We know that you are very familiar with the reaction of burning of magnesium ribbon, isn't it? So what happens when a piece of magnesium ribbon is burnt? What happens? So we know that magnesium ribbon burns with a dazzling white flame, isn't it? And a white color ash is produced, which is magnesium oxide. So generally when a metal reacts with oxygen, we can write metal oxides are produced. For example, magnesium plus oxygen gives magnesium oxide. Okay. Now we are going to compare the strength or how does each metal react with oxygen. Okay. Now potassium and sodium, the first 2 metals, okay, react violently with oxygen. Therefore, they cannot be even kept opened. They are kept under kerosene. Okay, to avoid the contact between water and oxygen, these metals are kept under kerosene, right? Even after keeping it opened in air, what will happen? They will catch fire immediately. So this is the reaction. Potassium plus oxygen will give you potassium oxide. Okay, potassium plus oxygen will give you potassium oxide. How to balance? Okay, don't expect me all the time I will balance the equation. You already learned in first chapter, so you have to balance. Okay, now what about sodium? Similarly, sodium also react with oxygen to form sodium oxide. Balance it. Okay, not balanced, right? So remember, these two reactions are violent reaction. Okay, violent reaction. Vigorously they will react and catch fire sometimes. Okay, so violent, I can write here violent reaction. Okay, now what is the third one? Calcium. Calcium does not react violently with oxygen. It reacts with oxygen but not violent reaction. Very fast reaction, okay, but not violent. So this is the reaction. Calcium plus oxygen will give you calcium oxide. Okay, here also. So here this is calcium oxide. Remember, no violent reaction. Okay, now so calcium is over. Magnesium, aluminum, zinc and lead. Okay, iron, the case is different, that we will discuss. Magnesium, aluminum, zinc and lead, they react, okay, when they are heated, they combine with oxygen to produce the metal oxide. For example, you know that magnesium on heating will burn in air to produce magnesium oxide. Moreover, if you are keeping opened these metals, okay, what are they? Magnesium, aluminum, zinc and lead. They will slowly react with the oxygen from the air and makes an oxide coat around the metal. Okay, so if you keep opened aluminum, what will happen? Aluminum will slowly react with oxygen to form aluminum oxide. Okay, remember, there is a particular advantage for this oxide layer, because this oxide layer acts as a preventive layer for further corrosion. What does it mean? I'll tell you. Suppose magnesium is exposed in air. What will happen? Slowly it will react with oxygen to form magnesium oxide, and that magnesium oxide will prevent from further corrosion or further reaction. Clear? That is why from the lab, I think in 9th or 8th, when we did the burning of magnesia ribbon, what we did, before burning, we cleaned with a sandpaper. Do you remember? Why did we use a sandpaper to clean magnesia ribbon? Because magnesium oxide layer is formed due to the exposure of magnesia ribbon. So that this magnesium oxide will hinder burning. So we want to remove that magnesium oxide. Right? So aluminum oxide, here in the case zinc oxide and lead oxide. Okay. What is the reaction here? Mg plus O2 will give you MgO. Okay. Then 2MgO. Right. Then what about aluminum? Aluminum plus O2 will give you Al2O3. Aluminum oxide chemical formula Al2O3. Why? Because aluminum is having valency 3 and oxygen is having valency 2. We will interchange the valencies while writing a chemical formula of a compound, right? So how to balance that? Here 3, here 2. So both side making 6. You can put 3 here and 2 here. So here 4 aluminum, right? 2 and 2 into 2, 4 aluminum. 4 aluminum plus 3 O2 gives 2 Al2O3. What about lead? Lead Pb plus O2 will give you lead oxide. Okay. So remember, on heating they will react readily, but on keeping in open air, slow reaction will take place and it will react with oxygen and a oxide layer will be formed around the metal, which will act as a preventive layer for further reaction. So it's an advantage for that. Okay. So for example, if magnesium is kept open, magnesium oxide will be formed, which will act as a preventive layer for further corrosion. Remember that. It's a very important point. Okay. In the case of iron, what will happen in the case of iron? We know that rusting, if iron is exposed to air, what will happen? After some time or some days, you can see rust appeared on iron, isn't it? The metal iron. Okay. So what reaction is there? It is also a type of oxidation, but not only oxygen is added to iron, but also water is added here. Okay. So XH2O. Okay. So what will happen? Now Fe2O3 dot XH2O will be formed, which is called rust. Okay. So here iron will combine with oxygen, slow reaction, not only with oxygen but also with water content, vapor or moisture content from the atmosphere to produce rust. Okay. So how will you balance it? 4Fe then 3O2, right? So Fe2O3 dot XH2O, which is called hydrated iron oxide, also called rust. Okay, this is the chemical reaction. And so we have discussed till lead. Now about copper. Copper usually when exposed to air, it will not react with oxygen, but at high temperature, copper reacts with oxygen to produce a black colored copper oxide. Okay. So remember, at high temperature only. See here, copper reacts with oxygen at high temperature to produce copper oxide, which is a black color compound. Okay. Now the chemical reactions of metals, and below mercury, silver, gold, platinum, they do not react with oxygen even at high temperatures. Okay. One more time. Sodium and potassium, vigorous, violent reaction, will catch fire immediately if they are kept opened. So sodium oxide and potassium oxide are formed. Calcium, no violent reaction, but calcium oxide are formed. Okay. Then magnesium, aluminum, zinc and lead, they will react slowly to form an oxide layer, which acts as a preventive layer for further corrosion. Okay. Then in the case of iron, what will happen? Rusting will take place. Okay. Then copper, at high temperature only, copper will react with oxygen to produce copper oxide, which is a black colored compound. Hope you understood the chemical reactions of metals with oxygen. Okay. We discussed in detail. Okay. If you have any doubt regarding the chemical reaction of metals with oxygen, please add as a comment so that I can clarify that. Alright. Then we know that metal oxides. Okay. Metal oxides. What is the nature of metal oxide? Okay. Metal oxides are, we learned in which chapter? Second chapter. Metal oxides are what? Metal oxides are basic in nature, right? Basic in nature. Why they are basic in nature? Let's take one example. For example, magnesium oxide. Okay. When reacts with an acid, hydrochloric acid, for example, what will happen? What is the product formed? Magnesium chloride, okay, magnesium chloride and water are the products formed, okay, magnesium chloride and water are produced, okay. Here, so how to balance that one? 2 HCl, right, chlorine here too, so we want to make chlorine 2 here. Now make MgCl2, right, H2O, it is balanced, okay. So here when metal oxide react with an acid, salt and water are produced. Where did we see this reaction? Salt and water are the products in neutralization reaction, right? So here this is an acid, we know that. So here magnesium oxide is acting like a base. That is why we got the product salt and water. That is why generally we are calling a metal oxide as a base. Is that clear? Now, the statement all metal oxides are basic in nature is not correct. All metal oxides are not basic in nature. Some are amphoteric in nature. What is amphoteric? We will see. Okay. So, amphoteric, new word for you. So, metal oxides can also be amphoteric oxides. Amphoteric oxides. Okay. Amphoteric oxides means they will show both the properties, I mean basic properties and also acidic properties. So, here for example, aluminium oxide and zinc oxide, okay, remember aluminium, metal oxides such as aluminium oxide and zinc oxide, okay, form amphoteric oxides. Let's see with chemical equations why they are amphoteric oxides, okay. Here for example, let me take zinc, okay, oxide, okay. When it suppose it reacts with an acid, hydrochloric acid, what will happen? Zinc chloride and water will be produced, right. So here zinc chloride plus water. So on balancing you will get 2HCl and correct, okay. So here what is zinc chloride? Salt and water, right. So in this case hydrochloric acid is an acid, right. So in this case, you know, here this is acting like a base, that is why we got salt and water, isn't it. So here zinc oxide is a base, okay. I'll tell you another example. For example, if zinc oxide is reacting with sodium hydroxide, what is sodium hydroxide? A base, right, which is a base, okay. Now what will happen if zinc oxide reacts with sodium hydroxide? Two products are produced, they are sodium zincate, okay. What's the chemical formula? Na2ZnO2, Na2, so here 2 should be there, Na2ZnO2 and water are produced, H2O are produced, okay. So sodium zincate is a salt. Here also what happened? Salt and water are produced, right, okay. Now here zinc oxide is acting like an acid, isn't it? So depends upon the situation, the behavior of this metal oxides will change. If it reacts with an acid, it will act like a base. If it reacts with a base, it will act like an acid, right? So such metal oxides are called amphoteric oxides. They will show at the same time acidic properties and also basic properties. I told you one more example, which is that aluminium oxide, right? Hope you understood this very clearly. Okay. Now In the case of aluminium, let's see what will happen when it reacts with an acid and a base. Okay. Now aluminium oxide is having a chemical formula Al2O3. Suppose it is reacting with hydrochloric acid. Okay. Now what are the products formed? Aluminium chloride and water. Okay. Two products are formed. Aluminium AlCl3 plus water are formed. Okay. Now please balance the equation. Alright. This is salt and water. So balancing the equation is a homework for you, right? Salt and water. Okay. Now here HCl is an acid. So here aluminium oxide is acting like a base. Okay. It is acting like a base because when it reacts with an acid, it produces salt and water. Now let's see what will happen when it reacts with a base. Okay. For example, if you take aluminium oxide and added with sodium hydroxide, which is a base, okay, what will happen? Which salt will be formed? Sodium aluminate will be forming. Okay. So here the chemical formula is NaAlO2. Sodium aluminate. Don't forget. NaAlO2. Okay. Plus water. What is this? Sodium aluminate, which is a salt. Also water are produced. So here base is already there. So here what is the role of aluminium oxide? It is acting like an acid, isn't it? So aluminium oxide is acting like an acid here. From this examples you can see it is an amphoteric oxide because sometimes it will act like an acid and sometimes it will act like a base. Okay, depends upon the chemical which it is reacted with, right? So when it is reacted with an acid, acts like a base. When it reacts with a base, it will act like an acid. Is that clear to you? All right. Today only one more point we are going to discuss, that is what is an alkali. You already learned water soluble bases are called alkalis. We know that all the metal oxides do not dissolve in water. Okay, but very few metal oxides like sodium oxide, potassium oxide, etc., they dissolve readily in water to produce the hydroxide form. For example, if sodium oxide is added to water, it will dissolve in water to produce sodium hydroxide. Okay, so such metal oxides which readily dissolve in water are called alkalis, or water soluble bases are called alkalis. Is that clear? Now in the coming class we will discuss the rest of the topic. Thank you and have a nice day.